Dear friends, once you have seen our presentation and grasped the basic scientific conclusion that coal comes from plants, you might still be curious how green living organisms could eventually become shiny black coal. You might also want to know what kind of physical and chemical changes take place during this process and why these changes are significant. In the Earth's more than 4 billion year history, innumerable world-shaking changes have taken place. These gave rise to a myriad life forms, including coal, which came to play an integral part in humans' lives. So how did coal, or black gold as it is also known, come to exist? Let's look for our answer in some plant fossils discovered in a coal seam. From about 345 million to 2.5 million years ago, the Earth experienced the Carboniferous Permian, Triassic, and Jurassic Cretaceous periods, the three main periods of coal formation. At the time, the climate was mild and wet, with ample sunlight and rainfall. Because low-lying marshes contained an abundance of nutrients, they were especially well suited for plant growth and reproduction. They became the areas where plants grew the most profusely. Many grew to heights of over 30 meters. Along with the erratically changing environment, these plants, like all the myriad life forms, underwent cyclical life and metabolic processes. Natural processes caused the plants in marshes to constantly accumulate layer upon layer. Aided by anaerobic microorganisms in the water, a series of biochemical reactions took place, and the plants gradually transformed into a dark brown mud-like substance called peat. This was the first stage in the plant's transformation into coal, the peat phase. Various forces then caused the peat to become buried deep underground. Pressure from sedimentary rock and high temperatures subjected it to pressing, dehydration, and recarburization. As a result, the originally loose peat layer gradually solidified into brown coal, thus completing the second phase of coal formation, the diagenetic phase. For brown coal to turn into today's bituminous and non-bituminous coal, it had to pass through the third phase of coal formation, the metamorphic phase. In this phase, brown coal is continuously subjected to high pressure and temperatures. Water is continuously lost or evaporated, and carbon content increased. Spread over different geographical environments, only some of the ancient plants became coal, others became fossils, and many just gradually disintegrated. under similar temperature and pressure conditions, how did bituminous and non-bituminous coal come to pass? Here, we cannot ignore the role played by time. If we divide the Earth's 4.6 billion year history into a 12-hour time frame, taking midnight as the starting point, coal formation didn't start until about 11 a.m. And the history of mankind lasts barely 1 minute. Plants continuously engage in photosynthesis, absorbing solar energy, CO2 and water, and releasing oxygen. Coal is precisely the opposite. When burned, it uses oxygen and releases CO2 and thermal energy. Thus, we can see that the solar energy absorbed by plants hundreds of millions of years ago was preserved to the present in the form of coal. Once burned, this energy is released, another expression in nature of the law of conservation. Over hundreds of millions of years and innumerable changes, the Earth used her amazing powers to give us an abundance of coal resources. These are now employed in a variety of applications, but coal is a non-renewable resource. We must cherish the precious bounty which nature has blessed us with and strive to use it efficiently.